Haha, you couldn't wait, could you? So how do we use that LCD to add and subtract fractions in general when those denominators don't match up? Well, let's take it step by step. So let's look at our first one. We got 1/4 plus 3/8. So 4 and 8 is a nice pair. 4 goes into 8 evenly, so we know our LCD is equal to 8. So we should be able to change all of our denominators to 8s. Now the second fraction was already an 8, so all we got to do is just carry the top down as is. But what about the first fraction? We changed the bottom from a 4 to an 8, so what should the top change to? You got it. It's going to change to a 2 because we're multiplying it by 2. So now the denominators are the same, so now we can add the tops. So this should give us 5/8. Done. What about this one? What's our LCD going to be for that? You got it. LCD better be 20. 5 goes in evenly. So we got 20 for the first one. We got 20 for the second one. The first one doesn't change. So what's our new numerator going to be on this one? We got to multiply by what? So we're multiplying by 4. So we better get 4 over 20. 13 minus 4 better be 9. So 9 over 20. Okay, not too bad when those denominators are kind of nice pairings. Let's see some other ones. We got 4/5 plus 2/3. Ooh, so what's the LCD on that one? Now, something that you might have guessed is that sometimes you just flat out multiply the denominators and that will give you the LCD. It doesn't always happen though, so you want to be careful. Sometimes it'll give you this ginormous denominator when you could have gotten one that was a lot smaller. So that goes back to our little method of finding the LCD. But in this case though, the LCD is 15. So now we got to change both of our denominators to 15s. And then what are the tops changed to? Now be careful, don't get lazy and just carry down the 4 and the 2. That's a common mistake people make. If you change the bottoms, you gotta change the tops. There's no way around it. So times it by 3 and you better get 12. Times it by 5, which will give you a 10. So in this case, you're gonna get 10 and 12 is 22 over 15. Now, again, we haven't learned about fixing these improper fractions where the top's bigger than the bottom, but we're going to see that in upcoming videos. So for now, let's leave it alone. All right, let's keep going. 16 and 4. LCD. Yeah, you're getting the hang of it. 16. So the 7 stays. 4 changed to a 16, so the 1, we're going to have to multiply it by 4, right? Times it by 4. And so now, -7 and a +4 is what? Better be -3. -3/16. All right, let's keep trucking. 8 and 3. Ooh. LCD 24, right? Can't find anything smaller than that. So let's change them to 24s. Try not to snap your lead. All right, what's our new numerators? First one has to get multiplied by 3. So 15, right? Next one gets multiplied by 8. So 1 times 8 is 8. And now what do we get for that one? So be careful, -15 and a -8. So you're going in the hole and then you're going further into the hole. So it should be a -23, right? Negative 23 over 24. Okay, so far so good, hopefully. What about this one? 2 minus 6/7. Well, we can kind of cheat like we did with the multiplying and dividing. Let's put this 2 over 1. So now we have a fraction. So what's our LCD between 1 and 7? It's 7, right? We can change a 1 into a 7. So our second fraction stayed the same, but what's our new top going to be? Our new numerator. If we had to multiply this by 7, which means we had to multiply the top by 7, so we better get a 14 on top. So now 14 minus 6 is 8, and we keep the same 7. And again, it's improper, but we'll fix it later. Let's try a 3 fraction one. Ooh. Well, like our example from LCDs, can we find a pair that kind of go together nicely? Yeah, 8 and 40, right? 8 goes into 40 evenly, so we can kind of ignore this 8. All we really care about is 30 and 40. So what's our LCD between 30 and 40? Well, 30 doesn't go into 40 evenly, so what's the next multiple? That'd be 80. 30 doesn't go into 80, so next multiple would be 120. 30 goes into 120, so that's our LCD. And so now all of our denominators got to change to 120s. So what's our new tops? Well, to go from 30 to 120, we'd have to multiply by 4. So that makes this into a 20. 40 changes to 120 if we multiply it by 3. So this better become a 9. 8 times what is 120? I'm pretty sure it's 15. 1 times 15 is 15. Okay, we got all of our tops fixed. All of our bottoms are the same, so we're almost there. 20 plus 9 is 29. 29 and 15 is 44. So 44 over 120. Are we done? No. We got to reduce that. What goes into those? I am pretty sure 4 does. So if we divide by 4, we're going to get an 11 on the top, and we'll get a 30 on the bottom. Now it's done. Oh, right. X's and letters, and we'll do it. We can do it. All right. In this case, the letters match up, which is good. That's a good thing. But this one's got a number and this one doesn't. How can we fix that, though? If we just multiplied this by a 2, that makes it into a 2x, and then it matches. So in this case, our LCD is actually 2x. So the first fraction doesn't change. Second fraction, the denominator is a 2x, but what happens to the top? Well, again, we had to multiply it by 2, so that makes it into a 16. So 5 and 16 better be 21. And remember, you don't do anything with the bottoms except just carry it down. So that should be it. And again, it's improper, but don't worry about it. Let's do it again. So what do you think the LCD is for this one? Yeah, 7x. So we got 7x on the first, we got 7x on the second one, but our numerator should change to, you got it, 21. Timesing it by 7. So now, just be careful, 2 minus 21. 2 minus 21 better be negative. It's going to be a negative 7, or excuse me, negative 19 over 7x. All right, one more, and that wraps up this section. What on earth are we going to do with an x and a y? Two different letters. But what did we say way back up at the beginning? If you're really stuck, what can you do with those denominators? You can just multiply them together. So in this case, that's what we were going to do. We'll just multiply them together as xy. That's our denominator that we're going to use. So xy for the first one, xy for the second one. But now let's be careful about the tops. So how did we actually change this into that? Change that x into an xy. We have to multiply it by y. But if you multiply the bottom by y, you got to multiply the top by y. So the top is going to change to 3y. So what about the second one? What's that going to change to? You got it. 4x. So again, this one had to get multiplied by x. Now don't worry about it being reversed. It's okay. Remember, the commutative property allows us to flip-flop things around, so we're fine. Okay, so this is our new problem. So now what's our final answer? We should hopefully know that the bottom is going to be xy, because we don't have to mess with that. But what about the top? Think of fruit. If you got 3 apples and 4 oranges, hopefully you're not saying 7 apple oranges. That would not be right. There's no way to combine them. So you're going to have to say 3y plus 4x all over xy. I know it's not satisfying, but that's the way it is. Don't try to just smush it all together. It's not going to work. Two different fruits. So, alrighty, that wraps up 4.4. More videos to come.